Hello everyone and welcome back. So in this video we are going to learn about how to create recursion tree for the Fibonacci series. Now we have earlier created recursion tree, but that was for a simple problem. In Fibonacci series we have actually made two recursion calls as we have seen in the last video, and the importance of recursion tree is that it will be asked to draw in an interview, as well as it helps you to make your concepts of recursion a lot clearer. So now let's get started. First I'm going to copy the code which we have written in the last class. So let me go back. So this is the code which we have written in the last class, and based on this actually the recursion tree gets created. Okay, so if anyone is asking you to draw the recursion tree, it's always very important that you have the code or you have the idea, okay, the way in which you're going to write the code, so you can use the same to draw the recursion tree. Now let me copy this code as well. Great. So this is the code which we have written, and based on this we are going to make our recursion tree, right? So we have actually called for 4. Let me just start from that only. Now the next step is actually, if we see via code as well, it's that we are calling for last first, right? So we are calling for last. Okay, so that's why we are going to draw 3. Now the biggest problem or biggest mistake which students do is that they draw directly after this. They think that the call is going to get made to 2, but that is not what is happening. When we are calling for Fibonacci of 3, what exactly is going to happen is that another instance of this particular function is going to get created for 3, and that is where the flow of the program will go, right? So on a similar based on similar thing, what we are going to do exactly is that we are going to make the call first for 2, but that is going to go from 3, right? So let me remove this as well. Now this is important because you should be aware that how the calls are going to get made in our function, okay, based on how you have written it. If you would have written second last first, then we would have made a call to 2 directly from 4 and then to 0 directly. Okay, now this is going to get called for this is going to call to 1. Now 1 we know is a base case. So what's exactly going to happen here is that it should return the value as 1 here. And along with this, I will also write the function calls as well. Let me use green pen for that. So this is the very first function call. This is the second function call. This is the third one. This is the fourth one, right? Now, once this 1 is returned from your node of this particular one, which 2 called, 2 has the answer for last, right? It is 1. Now it's going to call for 0. Because it has gotten the answer along with this code, it has gotten the answer for last. It's going to call for second last, and it's going to return with answer 1 as well. Since 2 has now got both the things, last and second last, it's going to calculate its answer. The answer is going to be 2, right? And it's going to return that answer to 3. Now 3 has in a similar way got 2 as an answer, and to get the answer for second last, it is going to make a call to n minus 2, which is going to be 1. Now again, this 1 is a base case, and I hope you get the idea now that it's going to return with answer 1. So my 3 node also get both the things, that is last and second last, and the answer is going to be 3 here, which is going to get returned. This answer is going to get returned here, which is going to be 3. Now in a similar way, we should also write the calls as well. So this calls is going to be 5th, whereas this call is going to be 6th. Now I'm making everything with a different color pen so that you are able to actually understand that which I would say pen denotes what. So green is actually denoting the number of function calls, yellow is denoting the answer, and your orange is denoting what exactly is getting result and what are the intermediate values which you are getting, right? So now 4, once it get the answer for L is equals to, I would say 3, it should now call for n minus 2. So now the flow will come to the second last line, and it's going to call for 2 here. Now this 2, again, it's not a base case. So it's going to first make a call to minus 1. First going to make a call to n minus 1, which is 1. And then it's going to make a call to 0. Now we are aware that, okay, both of these are base cases. So they are going to return 1 and 1. 2 is going to get answer L is equals to 1 and SL is equals to 1. Finally going to calculate its answer, which is going to be 2, and return this value as well. So now our fourth, the main node has the value of 3 L and second last, last and second last both, and it's going to return the final answer, which is going to be 5. Now in this whole flow, the thing which I want all of you to understand is the flow of functions. Okay, so the one which I'm writing from green pen, and let me show you the same as well. Okay, so the way we can see and find the same in code, let us just check the same via code. We can maybe define function call number is equals to 1, and in the starting only, what all we have to do is the function call is for So I'm just writing this code in the starting so that we are able to see for which all the call is getting made. So it's just going to help us to actually check our code. Let me just zoom out a little bit. Yeah, it's just going to help us to check our code. And if I will run it now, we are going to see that the first function call is for 4. Okay, next one is for 3. The next one is for 2. So if we see, the first one is for 4. Okay, next one is for 2. And let me copy this as well so that you are able to see the same thing. So if we see the calls, and this is very important to match and make sure that you understand this fully, that if you will see the calls, right, the sequence of the call, that will actually make a lot of things clear, and it will be a lot helpful when we tomorrow solve the question for I would say arrays or strings. Now if we see here, the first function call is made for 4, and that is what even we have written. Okay, I think, okay, I forget to do one thing, we should do that. 1 second. I forget to just basically increase this call equals 1. Okay, but anyways, I think that should be anyway helpful. So we can see the next call is made for 3. Okay, so we have also drawn 2 here. The next call is for 2, which we can see here. Then the call was made for 1. This is the one which has been talked about. Next call after that is for 0, which is actually coming here. So this is the 5th call. Then again, this call is made for 1, which is your this one, right? After that, the next call is for 2, which is this one, as we have written the 7 here as well. Like after this 6th, this call is made because this is still waiting in the, I would say, function stack. Then finally it is made for this one and this 0. Okay, so don't make the mistake where you are saying that 4 is going to call to 3 and then the third function call is going to get made to 2. No, that is not the sequence. And recursion tree in total, if you will try to make it for the first 5-10 problems which you are going to do, that is going to make your concept in this a lot more clear. Okay, so now because we have corrected the code as well, if I run this now, function call number. Okay, I think, yeah, I know the reason for this. So it is just the scope of variable, nothing else. So now it's working, everyone. So just that we cannot change it. We can use it. If you want to change it, we want to make sure that it is in global scope, right? We have to define and refer to it via global. You must have learned of this in the scope of variables. Okay. If not, just please make sure that you revise the classes. And now you can see how this overall the classes, like the calls and everything is going to get made, right? Again, this thing is very important. So please make sure that you draw this once as well. Okay. Now what we can do is just override this here, so that all of you can understand from this when you see these notes, right? So yeah, I hope with this is clear. Now let me just show you this by taking it a one step more further on the Python tutor, because that will help you in visualizing a lot. Okay, so pay attention, everyone. Now what exactly is going to happen? First, when we make the call, 1 second. Yeah, that's better. So function call number 1 gets defined. Now the function is going to get defined. After that, we are calling Fibonacci of 4. Okay, 4 gets called. 4 goes. It will print that first function call is 4. It will check for base cases, which is not the case. So base cases are not, of course, gonna pass. Then it's called for the last. Okay, so last it's gonna call, which is gonna be 3. And you will see another Fibonacci function for 3 is basically gonna get called. So n is 3 here, right? Now if we move forward, again the same thing is gonna happen. Okay. Now this whole function, right, this whole Fibonacci function is working for 3 for this block. It's going to go forward, check for base cases. Of course, that is not right. It's going to call for its last, which is 2. So it is actually, if you will see, just following this path, right, the one which we have drawn here. Okay, so drawing this without actually running the code is very important, and you will understand that once you keep on writing the code and you also see me drawing these trees and explaining you all the questions. Now if we move forward, we will see that okay, it is gonna get called for the next part, which is gonna be gonna check for base cases. Okay, last is going to be 1 for this particular case. 1 is the base case, it's still gonna print it. 1 is going to be the base case, so it's gonna return 1, and the flow is gonna go back to this particular function with value 2. Once it has gone to 2, it has gone the value of last as 1. It is going to get the value of last as 1, right? So it is able to get this value, and it's gonna make the next call for second last. So as of now here, this value has been returned, which is 1, and we are now gonna call for second last, which is going to be 0. So once I call for 0, once I call for this 0, you can see that exactly it's also the base case, so it's going to return 1. Similarly, now it has got both the cases, so n with 2 has got both the answer, which is last and second last, both are 1. So it's going to return the answer, which is going to be 2, right? So answer is going to be 2, and we can see that once we got the answer, the function call with n is equals to 3 got the last value as 2. So it's going to call for second last, which is going to be 1. For 1 again, it's going to return the value, right? It's going to return the value. Once it returns the value, of course, we are going to go forward. We got the answer value for last and second last both, and we're going to return the same as well. Now our initial function with n is equals to 4 got the value of last, so it's going to make the call for second last, and this is exactly the whole flow the way it is happening. It's going to call for second last. So now Fibonacci is called for 2. 2 is going to subsequently make the call because it's not the base case. It's going to make the call for 1 and 0. Both of them are going to return value as 1. So we see that okay, it is returning the value as 1. In a similar way, second last for 0, it's also going to get return the value of 1. So last and second last both are returning 1 to our this function with 2 on the right side. So this 2 is the function which we are talking about. So this 1 return the value as 1, 0 return the value as 1. And now using this particular thing, what we will be doing is we will be calculating our answer and return it to our main, the very first function. So it has the last value already. We are going to get the second last value. Now once we get the second last value as well, so 3 and 2, we are going to find out our answer and return the same. And our final answer is going to be 5, which we can see in front of us. Okay. So great everyone. I hope with this drawing of recursion tree, by seeing this in the terminal, the answers as well as through Python tutor visualization, how to actually think about the recursion tree is clear. Now what I want from you effectively is that for any problem which we are going to do as part of this course, and along with few problems which you're going to try, which I'm going to give you an assignment, you have to make sure that you draw the recursion tree. Even if it is clear, I still want you to draw it because this will help you to understand the concept of recursion a lot more. And once you have done it for 10 to 15, I would say questions, you will be a lot comfortable in that. And then you should be good to not draw and actually think of the, I would say, answer and the tree in your mind. And then you can basically move ahead with that, right? So yeah, with that, I hope overall the concept of recursion tree is clear. You have to make sure that while writing the code, we are not thinking of any of these. That is for where PMI is, because you can think that if you keep if you start thinking of this thing when you're writing the code, how much time will you take for writing the code, right? And I don't want you to do that, because in interviews we have to make sure that we are able to actually write a runnable code and explain that. And if the interviewer is interested in understanding the same, we should be more than happy to explain the full working and everything using recursion tree. Okay, so cool everyone. Let's meet in the next video where we are going to learn about and do some more questions on recursion.